Hi, welcome back to the shop. As I said in the last video, we're back on track with the project videos, and today I want to start a new kind of semi-big project. My new milling machine doesn't have power feeds, so I want to adapt this motor. This is a wiper motor from a car to the x-axis. You can't direct drive you can't direct drive the axis with this motor. It has plenty of torque, but it also has a worm gear in here, and the motor can turn the shaft, but you can't turn the shaft because the worm drive in here is self-blocking. You can't turn it. So when this is mounted to the axis, the drive spindle, you can't turn the hand crank because this is blocking. For that reason, you need a clutch between the motor and the spindle, a dog clutch. So let's take a look at the drawings and have a start. We have the sleeve here, which slips over the drive spindle and holds a key. I will machine a keyway into this, and then there will be a brass key put into it. This provides drive to this movable clutch piece. This clutch piece will slip over this sleeve, and while it transfers the rotational, it rotates, it's still movable axially. And there will be teeth cut into the face of this that engage into this piece. This will be the clutch that's mounted to my motor. Okay, let's have a start, and first we machine this sleeve. Okay, right now I'm roughing down the material for the spindle sleeve. The material I'm using is a piece of a really big screw. This is, here on the end you can see some remain of the thread. This is an M36 by 1.5 millimeter threaded rod. I get this from a friend. These are used to mount cranes, big cranes onto the beds of trucks, and they have a high strength because they have to take a lot of load, and the material is absolutely wonderful to machine. It's short chipping. It gives nice blue chips. Even as I'm machining it with high-speed steel, the chips come off the tool silverish, and as soon as I land on the machine, and a few seconds later, they turn blue, so all the heat goes into the chip, and that's a very good sign, and it doesn't seem to affect the tool at all. So this is really a good material. Okay, I'm down to 26 millimeters and target diameter is 25 millimeters minus 200ths. I'm going to take a skim pass, measure, and do a final cut. Okay, we have 25.52 millimeters. And we have a final diameter of 25, or should I say 24.99. That's perfectly the right diameter. Yeah, that's perfect. Okay, now we turn the piece around. Turn the bigger diameter, face it to length, and drill it out. Drill and bore it out to fit the shaft of my milling machine. Okay, let's turn down the outer diameter of this. Okay, 30 millimeters. Okay, first skim pass. That will cut your finger right open. Okay, we have 33 millimeters. Yeah. 30.06 millimeters. That's okay. This is not something critical. We change to a facing and chamfering tool. Okay, I just chamfered the left edge because there was a burr and I want to measure the width of this, flange. And we are 1.8 millimeters heavy. Oh, 2.8. Target dimension is 9 millimeters. Ooh, okay. Okay, take a quick measurement. That's 9 millimeters. That's okay. Let's put a chamfer on both sides. And now we can start to drill out the center. Okay, we step drilled the hole up to 16 millimeters and I used a 3-flute drill bit that's only for opening up holes. It has no center cutting flutes. You need a 10 millimeter starter hole for this one. Then you can drill up to 16 millimeters with that one. The 3-fluted ones run very smooth in comparison to a normal twist drill with 2 flutes. They tend to chatter and rattle when you open up holes. So for opening up holes, I prefer these, especially on my light machines. On a 2-ton iron-eating roughing monster, it doesn't matter. Okay. We start to bore out the hole with this carbide boring bar. We'll do a skim pass, take a measurement, and then we will open it up to final dimension. Ooh. 16.55, but we will counter check with the 2-point internal micrometer, because I don't trust the calipers for anything more precise than 0.05 of a millimeter. Okay, 16.55. Let's get some cutting oil going. Okay, this is the finished sleeve without the milling operations. The boring went, yeah, not perfectly. The surface finish is somewhat ugly, but it fits onto the shaft and it's a pretty good fit. Last thing that has to be done is to machine the keyway slot into here, and I'm not sure how I'm going to fix it to the spindle of the machine. Maybe 2 set screws 120 degrees apart. That's a good solution, or even better with a cross pin. I will see. Maybe the cross pin is the better solution. This is the left end of the machine's table. Oops, sorry. And this is the spindle, the feed screw of the table. And this is the flange we're going to mount the power drive to. We'll have to cut off this shaft. We'll just do this in situation with a hacksaw, and then we will clean up the file. Then we will fix that sleeve over here, maybe with a cross pin or with the 2 set screws 120 degrees apart. And then we have to add the clutch and the motor, and some way of mounting the motor to the flange, but I have an idea for that. Okay, we're over at the milling machine, and I clamped the sleeve into the vise, and we're now going to center on both sides and touch off on this surface. And I will show you a neat thing about DRO to center workpieces. Okay, I touched off on the first side and zeroed my DRO. Now I will come over. Again, going down, touch off on the second side. And I'm not zeroing the DRO. Okay, as we touched off on the second side, we got this number 30.97. That's the width of our part plus the diameter of the edge finder. And now to find the to center our axis, we switch to calculator mode, enter our number, divided by 2. That's half of this, and now we push this number over into the DRO. Now if we crank X to 0, we are right over the center of our workpiece. Now we can touch off on this surface, zero it, and we're ready to go. Okay, I set up an undersized 3.5mm end mill. We're going to machine a 4mm keyway, and I want it to be pretty tight, so we're hogging out the material with this undersized end mill, and then we will cut these sides to finish it. Okay, we plunged in 2 millimeters and now we move over Okay, I did only go by the numbers on the DRO, and this slot should be pretty much on size. Okay, this is our sleeve and this is the piece of material I'm going to make the key out, and as you can see this is a very tight fit. I don't want this key to be rattling around in this piece. It should be a nice slip fit in the other piece, but here I want a tight fit so it doesn't wear out the key. So this was the first video of this episode on the Powerfeed for my milling machine. I thank you for watching and see you next time when we do the clutch parts. Thank you for watching.